right, so continuing on, we briefly introduced the law of sines, again about an oblique triangle, a triangle that it doesn't necessarily have to, it doesn't have a right angle, an oblique triangle, but that law of sines that I just introduced to you in the last segment, you can use it on a right triangle if you wish to. What I want to spend a few minutes on now is the law of cosines, and then if we have enough time, might even be able to actually solve a triangle with some numbers today. Okay, so let's look at the law of cosines. Now, I'm not going to derive this one for you. The derivation is in any pre-calculus textbook, so you can just kind of look it up. Let me draw another oblique triangle, and I'll show you how I like to sort of casually think of how to remember the law of cosines. Again, oblique triangle, something like that. I'll label it a little differently this time. Why don't I call this side over here this time C, and then let's put A over here and B down here. Doesn't matter what symbols we use. We could use Greek letters or Chinese characters or whatever we wanted to represent these 6 parts, right? So we have legs, we have links, 3 links, and we have 3 angles. Labeled then using the capital letters like that. Okay. We all remember the Pythagorean theorem for a right triangle, So the way I like to remember the law of cosines is I might be thinking of my right triangle, right? Hypotenuse squared equals the sum of the squares of the other 2 legs, right? And oftentimes you might be thinking this, right? Now, there's 3 ways I could write that relationship depending on where the hypotenuse is. If this was a right triangle, which one of these would be the hypotenuse? If it was a right triangle? C, has to be. I could have those labels mixed around though, couldn't I? So I could have A squared equals B squared plus C squared sitting there like that. If this was a right triangle, the hypotenuse would be A, has to be, right? Okay, and then third option would be this way, right? Again, hypotenuse would have to be B for the Pythagorean theorem for a right to apply to a right triangle. Okay, so what happens, the way I like to casually think of this, and this is not formal math, and I don't even know if I should say this on a recording, because a math professor might get a hold of this and look at it and go, oh man, okay, anyway. If you distort the right triangle into something that's oblique like this, there has to be an adjustment made to this relationship. So what I'm trying to do is just giving you a little tool to help you remember the rule, okay? And the adjustment is easy to remember. You subtract off twice the product of these side legs right here. Okay? So think of it as a Pythagorean kind of relationship, and then just subtract off twice the product of these legs that you see on this side here. Okay. So this is the law of cosines in all its possible forms if using letters A, B, C. Oops, I forgot something. Otherwise, the professors could get after me, okay? I need to tag on here. Why do we call this the law of cosines? There better be a cosine in here, okay? And so what we have to do is tag on here a cosine of the angle associated with this opposite side here. Now look in the book, just to check me, see if my memory is correct. Look in the book, that section, and you should see this. Okay? So, how many items are in each of these equations? all three legs and one angle, right? All three legs and one angle. 4 goodies. You can use this equation if you know how many of those goodies. 3 out of the 4, right? 3 out of the 4. So, if you know, here's your law of cosines in its various forms. If you know all 3 sides, then the only thing missing would be a vertex angle. And you could then solve for that. Right? Let's see. What if you knew 2 sides and maybe an angle between them? 2 sides and an angle between them. Here's what I mean. If I knew all 3 sides, I might have something like, let me make it so it's not so right triangle looking. Okay? If you knew all 3 sides, that could be a well-defined triangle. And then the other thing I was commenting on is if you knew a side and next to it an angle, and then on the other side of that angle, the other side. So if I knew this information, do you see how? If I knew a side, an angle, and a side, then that would give me the rest of the triangle then, wouldn't it? By using this law. I'd know 2 of the sides and an angle that would be opposite that piece, right? The angle that's opposite that missing piece. Okay, so if I knew side, 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 I could use this law. And if I knew side, angle, side in that kind of order, I could use this law. All right. So all you do is drop the numbers in, and then you just have a little bit of algebra to do to work it out. Now here's a little question. What happens if you're in the lumber yard and you pick up 3 sticks, 3 straight sticks? Can you always form a triangle with those sticks?
Depends on their lengths.
Let's say I give you a stick that's this long, and I give you another stick that is this long, and then I give you a third stick that's that long.
You might be able to form a triangle inside of those 3.
I'm talking about touching the tips of the ends together. Will that always form a triangle? Now here, watch this. Let's say I give you a stick this long, I give you another stick this long, and I give you another stick this long.
Yeah.
Right? Right? So what happens to form a triangle, you've got to have the sum of 2 sides has to be at least as long or longer, actually longer than that third side. The sum of 2 of the sticks has to be longer than the third stick. Otherwise you're, okay? Right. So sometimes there might be conditions where side, side, side won't actually build a triangle. Okay, we ready to do something with some numbers? We've got enough time to do one today, and then we'll spend a little more time on it during the next session. Okay. So I've got the law of sines over here. I've got the law of cosines on the other board. I hope you can remember both those laws. They're not too hard to remember. And so somebody give me a length.
13.
13. So we're going to have a length of 13. Why don't we say it's inches? Somebody give me another length. 26 inches. Okay, and somebody give me an angle in degrees. 40 degrees, okay. So I've got 3 pieces that I'm going to build into a triangle. All right? So let's say I am going to lay out this 26-inch piece right here. And then off of one end of that, I'm going to draw roughly what I see as 40 degrees. And I'm going to draw something that is of length 13 roughly. That looks about right, doesn't it? With a 40-degree angle in there.
Mm-hmm.
Okay. So that forms a pretty good triangle, doesn't it? Okay.
Mm-hmm.
If we then connect that. Okay. Going pretty good? And what we want to do is we want to solve this triangle for its missing parts. There's not one way to do it. You can do this in a variety of ways. So the key here is to look at the picture, draw a picture, try to make it to scale so that you can have a sense of this answer over here and a sense of these angle values, right? I mean, look at that picture. That looks pretty accurate, doesn't it?
Mm-hmm.
So what might you guess for this length right here? Just by looking at the picture.
Close to 13.
It's like 14 or 15.
14, 17, 20, right? And what I can do is, what you can do if you make it small enough to use your fingers or a straight edge, you can actually eyeball it. I'm going to guess 15, which is right in ballpark of what you folks were saying, okay? That's a guess. Let's guess this angle right here. Looks like maybe 30 degrees?
45.
30,
35.
35 degrees, okay? Guess that. And eyeball this up here. A little more than 90, huh? 90, bigger than 90, isn't it?
That'd be 105.
105? 105? Okay. So use your brain, make a prediction. Now let's do the math. All right? Look at the order of the given information. How would we say that to ourselves? Thank you. Side, angle, side, right? Side, angle, side. That usually acts as a hint to help you a little bit on choosing which law to play with. Side, angle, side. So what I would do is I would label the unknowns. So let me call this angle up here at the top that we've guessed, let's call it capital A. Let's call this length right here little c, and let's call this angle B. And then that means this angle over here is capital C, or 40 degrees. Okay. Now, with that side angle side information known, what I could do by remembering that law of cosines over there is here's an unknown side, but we do know its opposite angle. So what I'm going to do is I'm going to use my law of cosines and I'm going to write it starting with this missing side right there. So c squared is going to be equal to 13 squared plus 26 squared minus 2 times 13 times 26 times the cosine of the known angle opposite side c, which is going to be 40 degrees. Now, I will show you how to use the calculator on this in an efficient fashion here in a second. So side C then is going to be the big square root of this mess, right? Which is 169. What's 26 squared?
676.
676. And minus 26 times 26 is 676. See, I see the 26 there, and times the cosine of 40 degrees, okay? So that's going to give us an approximate value for C. We'll get to the calculator in a second. What I like to do is I usually like to set up the whole solution process before I turn the calculator on. Okay. Now, once we know once we know that side C, we then know a side and its opposite angle. That's the clue. When you know that pair of information, an angle and its opposite side, then if you know one other piece of the puzzle, you can use your law of sines on it. You can use your law of sines on it. So, let's say I wanted to solve for angle A. My next step could be I could take the sine of angle A divided by its opposite side, which we can see is 26, and that's going to be equal to a ratio that I know both parts of. The sine of divided by, see, I need that combo of length and angle. My 40-degree piece, sine of 40 degrees, and its opposite side was that missing piece that we have now is the angle C from the previous calculation. I'm sorry, side C from the previous calculation. Yeah?
Why is it sine 40?
Because that angle's 40 degrees.
We knew this, we calculate, here when we punch it on a calculator, we're going to have a length for side C. We're going to know its opposite angle already. So that's the reason, if you know, think about the law of sines, folks. You have to know 3 of the 4 parts, don't you? So the clue to ever use the law of sines, as I mentioned a moment ago, the clue to using law of sines is knowing an angle and its opposite side, plus one other piece of information. Can you remember that? If you know an angle and its opposite side, you can use the law of sines. Okay. So then the objective here is to solve for A, isn't it? So then what we're going to get is the sine of A is going to be equal to the ratio of 26 over C, multiplying both sides by 26, times that sine of 40 degrees. And so angle A is going to be the inverse sine of that ratio, 26 over the C value, sine of 40 degrees. And that will give us a value for angle A. We'll be done here in about 1 minute. Okay? Got it? And then finally, what's missing? Angle B. Angle B is going to be easy, isn't it? Yeah. Angle B is going to just be equal to 180 minus the sum of 40 degrees and angle A. Right? Okay. So let's do that real quickly with the calculator, and then we'll be done for the day. I'm going to make sure I'm in degree mode on this problem. So degree mode, here we are. And now I'm going to punch this big square root of 169, hold it, plus 676, and subtract off from it 676 cosine of our 40 degrees, and I'm going to store it in alpha C in the calculator using the store key. There's the length. Then I'm going to punch inverse sine of 26 times the sine of 40 degrees, and I'm going to divide that by alpha C. And I'm going to store that in memory cell alpha A. There's that angle. And then I'm going to take and find angle B by taking 180 and subtracting from it the sum of 40 degrees and angle A. See how I use the memory cells of the calculator? I'm going to store this in alpha B. So here are our 3 answers. Up here, 18.09 inches. We have angle A is 67.5 degrees. And angle B, 72.5 degrees. And you check that out with our thinking, my drawing, side C, 18 compared to 15. Angle B, 72 degrees. Oh, my drawing's not too accurate. Okay. So anyway, if you draw an accurate geometry scale drawing, you'll be able to be much more accurate on those predictions. Okay. Have a nice weekend. We have a holiday next Monday. Okay, great.